In this video lecture, we will be learning impulse momentum equation. So, impulse, first we'll understand what impulse is. It is a term that describes the effect of a force which acts over a time on an object. So, here we see that there are two things particularly. One is force, other is time. So, these two aspects we are combining together, and that is nothing but the impulse. So, the formula for impulse is given as I is equal to F into T. So it simply is like how much force is acting and for what time it is acting on a particular object. So that quantity is what is impulse. Okay, and you must be now, of course, you understand that a force, if it acts for a long time on a certain object, it will definitely have different results than if the force is acting for a short time, right? So impulse is very important in such situations to quantify that for how much time that force was acting, and hence what should be the outcome of that force basically on that object. Momentum is also a familiar word. So momentum is the product of mass and velocity of a body in motion, right? So it is given as m into v, right? Now when a body is in rest, a static object will only have mass. We can describe the state of that object with the mass. Okay, but when that object is in motion, only mass is not enough for describing the state of that object. Velocity also comes into picture, right? So when an object is in motion, it cannot be described by only its mass, but velocity also needs to be taken into consideration, and hence the momentum. So from this we understand that momentum is important for objects which are under motion. Now momentum is something that cannot be changed unless force acts on it. This is what we understand even from the Newton's first law, which says that an object which is at rest will stay in the rest position, or the object which is in continuous motion and in a constant motion will stay in motion unless and until a force is acted upon it, right? So same thing, if the object is in motion, if it has a momentum, that is mass into velocity, it cannot be stopped unless a force is acting onto it. In realistic scenarios, if there is an object which is under motion, so this is mass and let's say this is velocity mv. So in realistic scenario, what is the force that is stopping the object? The frictional force. If we consider that there is no frictional force, then what is the force that would stop the object? Let us say that there is no drag force also. So horizontally, if we see, there is no other force which is acting, and hence this object will continue its motion till an external force comes and changes its momentum. I won't say stop it, but I would say change its momentum. So an external force can also increase this velocity, or it can also decrease the velocity, meaning that it can either increase the momentum or it can decrease the momentum. Hence from this we understand that a force is required to either increase the momentum of an object, or to either bring the momentum to zero, or rather to decrease the momentum. Now how are these two related? We'll see. Again we'll go back to the this equation, summation of F is equal to ma, right? In this what we'll do is A we will put as dv by dt, right? It is rate of change of velocity, and this dt I will take on the other side. So summation of F dt going from t1 to t2 is equal to integration of m dv going from u to v. So if there is an object which is there, and these are the summation of forces which is acting on the object, after a time of let's say here it was having time t1, after a time t2 it reaches this position. In the initial position it had a velocity of u, in this position it has a velocity of v. Okay, so by impulse momentum what we can say is summation of F into t2 minus t1 is equal to m into v minus u, right? So it is change in the momentum is equal to this impulse. So this statement we see that the force which is required, a force is required to either increase the momentum of an object or to decrease its momentum. So this is that force summation F which is changing the momentum of this object from mu to mv. Okay, so this is the force which is acting for time t2 minus t1, which is required to change the momentum of object from mu to mv. So if you see this equation, I have simplified this integral as m into v minus u, but I have not simplified this term, this integral, right? The reason is that if we plot a graph between our force versus time, then there can be a variation where f is function of time, okay, and impulse in that case would be the area under this curve, and hence this f can be a function of time. Therefore it won't be simply, it cannot be taken as constant, and we cannot write t2 minus t1 directly, okay. That would have to be based on the condition of how that force is there and how it is given. If it's a constant force, like if it's a straight line like this, then definitely we can take it as constant. So let us start with the numericals. What is given in this numerical is, if cylinder A is given an initial downward speed of 2 meters per second, determine the speed of each cylinder when t is equal to 3 seconds. Neglect the mass of the pulleys. Cylinder A and cylinder B, mass is given as 8 kg and cylinder B mass is 10 kg. The initial speed for A is u is equal to 2 meters per second. For B it is not known, and the time for which we need to determine the speeds is 3 seconds. So okay, let us take this datum and let us write their displacement equations. So if I take this as x a and if I take this distance as x b, what I will get is 2 times x a plus 2 times x b is equal to L. If I differentiate this, I will get VA plus VB equals to 0. So I get VA equals to minus VB. What I understand from this is that if A is going down, B will go up, right? We know this now. So what you can do is you can either consider B going up and A going down, and then when you draw the free body diagram of B, if you are considering B to going up, then this has to be the positive sign convention. I mean the sign convention for all the forces, upward has to be positive, and here since this downward, it is having a downward motion, so all the forces should follow downward as positive sign convention. However, what I will do is I will say that let both of them go down. So let A and B both move down. So in this case what happens is, if A is having u is equal to 2 meters per second, B will have initial velocity of minus 2 meters per second. Since VA is equal to minus VB, or rather VB is equal to minus VA, I should write, okay. And of course we also need to determine the final velocity at 3 seconds. Let us say that the final velocity of A is V. I will write here final velocity is V, and for B final velocity will be minus V, okay. So now we are considering both to be moving downwards, so I am taking downwards as the positive sign convention. Let us draw the free body diagram. So FBD of A and FBD of B. We have 8 into 9.81 as the downward weight, and then here we have 2T, correct? What else is there? Only that much, 2T and 8 into 9.81. So we are considering downward motion, hence downward forces are positive. So the FBD of A is complete. We can now apply the impulse momentum equation for A. So impulse momentum equation for A would be the forces summation F into the time. So forces, if downwards is positive, it is 8 into 9.81 minus 2t. These are the forces which are causing the vertical motion, multiplied by time, which is 3 seconds, because we need to determine the speed of each cylinder at 3 seconds. This is equal to the change in their momentums. So the momentum is changing from mu to mv. So m into v minus u, v minus 2 I will write here, correct? Same way, now let us draw the FBD of B. The downward weight is 10 into 9.81. Upward we have 2t. Okay. And the impulse momentum equation, I'll just write IME for B, would be, now again here we are considering the downward motion, so downwards are positive. Therefore, the impulse momentum equation for B will be 10 into 9.81 minus 2t into 3 is equal to m into the v minus u for B. So v, the final velocity is minus v, you can see here, minus v into, minus v minus u, which is again minus 2. So this will become plus 2 here. This is the impulse momentum equation for B. What we get from this is 235.44 times 235.44 minus 60 is equal to, mass is 8 into V, 8V minus 16. This is one equation that we get here, and here what we will get is, from impulse momentum equation of B, is 294.3 minus 60 is equal to minus, now this m is 10, so minus 10 into V plus 20, right? So if we arrange the terms into V and T, what we'll get is 8V plus 6T is equal to 235.44 minus 16, plus 16. This is one equation that we get here, 8V plus 60, and the another equation that we'll get is minus 10V plus 6T is equal to 294.3 minus 20. This is another equation, and when we solve both of them together, we'll be getting the velocity and the tension. So velocity you get is minus 1.27 meters per second, and T you get is 43.6 newtons. So now if you see, the final velocity of A was equal to V, which is equal to minus 1.27 meters per second. Since you are getting this as negative, and since we had considered downwards to be positive, it means that the movement of A at 3 seconds is actually upwards, and B is equal to minus V, therefore it is minus of minus 1.27. Therefore the final velocity of V is equal to 1.27 meters per second, which is actually a downward velocity, right? Therefore the motion of B is happening downwards and the motion of A is happening upward. This is after 3 seconds, okay, and which is actually quite relevant, right? Because 10 kg is greater than 8, so this B has to move down and A has to move up after a certain point. Let us solve next numerical. What is given in the question is, a small 9 kg block is placed on the inclined plane and subjected to 2.7 kg and 6.8 kg forces. Now the forces, obviously these are not the units of forces, but sometimes we do have something called as kgf. It means if a force is expressed as a kg or as a kilogram, then it is generally written as kgf. So this is the force by which it is being pushed. We will definitely convert this into newtons. That act parallel with edges AB and AC respectively. If the block is initially at rest, determine its speed when t is equal to 3 seconds. The coefficient of kinetic friction between the block and the plane is mu is equal to 0.2. Fine. So if I see this plane from this side, if I see the view from this side, it is called as side view. Okay. If I see it from this side, it is called as top view. So these two views would be very important for us. So if we consider the side view, okay, here we have 30 degrees of the inclination, and let us say that the block is placed this way, okay, and the weight of that block is 9 into 9.81, right? This is its downward component, and this is the side component. So here it is, I'll say W cos of 30, and here I'll say W sin of 30, okay, and there is also this normal reaction which would be happening. Let us call it as N. So let us find this N first. If we do summation Fy equals to 0, we will get N is equal to 9 into 9.81 into cos 30, which is equal to 88.169 newtons. This is the normal force, and we will have to multiply basically with the coefficient of friction to get the frictional force. But now let us see the top view of this. So when we check the top view, it will look like a square. Basically it will look like this, something like this, and let us say that the block which we are considering is placed here. Okay, now there is a force which is acting from the left side, that is your Fx, which is equal to 2.7 into 9.81. This is equal to how much? 26.487 newtons, and there is a force which is acting this way. It is 6.8 into 9.81, which is equal to 66.708. Fine. So we get our forces in terms of newtons. Now you understand that if there is a leftward force and an upward force acting on this block, the motion of this block is going to be something along this trajectory, and after a certain time, the time that is told to us is 3 seconds. So let us say that after t equals to 3 seconds, the block reaches this position. Okay. Now everything has to be resolved. When the motion is happening in this direction, the frictional force would be in this direction, right? Opposite direction. When the motion is happening upwards, the frictional force would be downwards, like this. This is the resultant frictional force. So here I'll say this is F mu x, this is F mu y, and this is your F mu. Okay, and F mu is going to be 0.2 times n. F mu is the one which is going to be 0.2 times n, because the movement of the object is in this direction. Okay, So whatever normal force is generated, that is causing the friction along this direction, along this way, right? So that has to be resolved into its x and y components for our easier calculation. So F mu x will be equal to 0.2 into n is 88.169 into, so what is this, how much is this, right? That we need to understand. So let us say that for now we do not know this angle theta. Had there been only this fx and fy which is acting, we could have easily found what is that theta by using the resultant or. But now along with this fx and fy, you understand that there is this f mu x which is acting this way and f mu y is acting this way. So these forces are also there, and without these forces you cannot calculate this angle theta, right? So for now let us say that we do not know that angle theta, and I'll call it as f mu x would be 0.2 into 88.169 cos theta. So this would be equal to 17.6338 cos theta. Similarly, f mu y will be 0.2 into 88.169 sin theta, which is equal to 17.6338 sin theta. Okay, this is what we got. We have resolved the frictional forces. Similarly, the velocity in this direction is Vx, the velocity in upward direction is Vy, right? So this Vx and Vy will also be having a similar triangle where it would be like this is Vx, this is your Vy, and this is your final. When we take the change in momentum, that is when we write this equation, impulse is equal to change in momentum, so we write it as m into v minus u, where u is the initial velocity. The initial velocity is basically the block is initially at rest here, as it is written initially at rest. So initial velocity is 0, there is no initial velocity, but final velocity we have v, and that is along this direction. Okay, so again this v has to be broken down into its components, Vx and Vy. So Vx will be equal to V cos theta and Vy will be equal to V sin theta. Okay, now what I'll be doing is I'll be writing impulse momentum equation along x direction, and I'll also write impulse momentum equation along y direction. Impulse momentum equation along x direction and impulse momentum equation along y direction. Along x direction, what are the forces that are acting now? We have this fx and we have this f mu x, right? These are the forces that are acting along x direction. So fx is how much? 26.487, and of course the direction of the movement is like this, so this is positive. So 26.487 minus f mu x is 17.6338 cos theta. These are the forces that are causing the horizontal or the motion in x direction. This has to be multiplied by time, and it is equal to m into, or rather let us write its mass directly. Mass is given as 9 kg, right? So 9 into Vx minus Ux. U is of course 0, so that component won't come, but Vx is V cos theta and U is 0, right? So this is one equation that we can simplify. Let us write for y direction also. So what are the forces that are causing the motion in y direction? We have this force which is 66.708 newtons. We have F mu y which is acting opposite to it, and there is one more force which many students tend to do mistake here, which is this force, the weight of that object along the y direction. You understand that this is your y direction and the x direction is basically coming towards you. It is in the three-dimensional space, and this would be the z direction. Okay, so the y direction, we do have one more force, which is w sine 30. So here the forces are 66.708 minus 17.6338 sine theta minus w cos theta is 9 into 9.81, sorry, w sine 30. So let us calculate this here itself, how much it comes. 9 into 9.81 into sine 30 is 44.145 newtons. So that is negative 44.145. This multiplied by the time, which is 3 seconds, is equal to 9 into v sine theta. That's it. And u is 0. Okay. So let us solve this. When we simplify it, we will get 8.829 minus 5.0973 cos theta is equal to v cos theta, and here on the other side we will get 22.236 minus 14.715 minus 5.0973 sin theta is equal to v sin theta. Okay, so let me just write this term together collectively. So that is 7.521. So 7.521 minus 5.0973 sin theta is equal to v sin theta, and here we have this equation. Okay, what we can do is let us try to solve them simultaneously. I will divide this equation by this equation, so we would get 7.521 minus 5.0973 sin theta upon 8.829 minus 5.0973 cos theta is equal to tan theta. Okay, and when we solve this entire equation, we can solve it in calculator. You will get theta is equal to 40.4261 degrees, and when you substitute this theta in any of this equation, you will get v is equal to 6.5 meters per second. Right? So this solves the numerical. Let us solve the next numerical. So what is given here is forces F1 and F2 vary as shown by the graph. So our forces are now varying along the or basically they are function of time. The 5 kg smooth disc is traveling to the left with a speed of 3 meters per second when t equals to 0. Determine the magnitude and direction of the disk's velocity when t equals to 4 seconds. Okay, so from this graph itself, directly we can find the impulse, right? The impulse due to force 1 and impulse due to force 2. It is nothing but the area under those graphs. So F1 is by this solid line, it is given by the solid line, and F2 is given by this dotted line. So we can find the impulse right away. First we'll write what is given to us. M is 5 kg. Okay, and yeah, so U is 3 meters per second, and it is basically in the x direction. Okay, so fine. Impulse I1 I will write. I1 is nothing but the area under the graph, this area like this. So that is given by half into 1 into 20 plus 3 minus 1 into 20 plus 4 minus 3 into 10, which is equal to 60 Newton seconds. This is your I1. I2 will be given by the area of the triangle, this area. So it is half into base into height, which is equal to 40 Newton seconds. Okay, now what I'll do, I have found impulse I1 is like this and I2 is this way. I will write the impulse momentum equation about x and about y separately. Okay, and we will consider the direction to be positive along positive x and along positive y to be positive. Okay, so impulse momentum equation in x direction will be given by F2 is acting in the positive x, so I2 will be positive 40 minus I1 cos 30, right, minus I1 cos 30, so 60 into cos 30. This is your total impulse that is acting along the x direction. This is equal to mass into the change in the momentum. So 5 into, let us say Vx is the final velocity in the x direction, Vx minus Ux I would say, and since 3 meters per second is in the x direction only, therefore we can write here 3. So we can find Vx from this. Vx comes out to be minus 5.33 or minus 5.3923 meters per second. It means that Vx is like this, in this direction to the left. When we apply impulse momentum equation along y direction, we will get there is no contribution by I2 here, so only due to I1, which is I1 sine 30. So 60 sine 30 is equal to mass phi into Vy, and u is 0, u in the y direction is 0. So Vy you will get as 6 meters per second, and since this is positive, it means it's upwards. So we can say the total velocity is under root of 6 square plus 5.3923 square, which is equal to 8.067 meters per second, and the angle at which it is acting, tan inverse of Vy by Vx, is 48.0534 degrees, and it would be acting like this, right? Because see, Vx is this way, Vy is like this, so V is this way, and this angle is your theta. What is given here is a winch delivers a horizontal towing force F to its cable at A, which varies as shown in the graph. Okay. Determine the speed of the 80 kg bucket when t is equal to 24 seconds. Originally the bucket is released from rest. So what all things are given is mass of that bucket is given, which is 80 kg, and initial speed of the bucket is 0. We need to determine at t equals to 24 seconds. So the impulse can be found out by this area of this curve. So impulse I is, it is 12 into 360, or rather 24 into 360, which is this rectangular area, plus half into 24 minus 12 into 600 minus 360, which is the area of this triangle. Okay, so the impulse I get is 10080 Newton seconds. This is the impulse. This is the impulse due to force F. Okay. If I draw the FBD of the bucket, what I'll get is, if I draw the FBD of this point, I will get there are two forces F this way, and there is one force acting downwards, which is the weight of the bucket, which is 80 into 9.81. So this is not the total impulse. What we are looking at, it is not the total impulse. It is the impulse due to one of the F. So the total impulse will be 2 into 10080. This 2 into 10080. And okay, now what is the motion of this bucket? It is moving upwards. So upwards we'll consider as positive. Therefore, this two forces which are here, those are positive. The impulse due to those two forces will be positive. So 2 into 10080 minus 80 into 9.81 into 24. This completes your total impulse. It is equal to mass, which is 80, into final velocity, which we do not know, and initial velocity is 0. Therefore, you will get final velocity V as equal to 16.56 meters per second. Fine. Let us solve one more numerical. So what is given in this question is, mass is given 0.15 kg. The baseball has a speed of 30 meters per second. Okay, so I'll consider that the baseball is coming here. See, what is exactly happening is, baseball is coming and this striker is striking that baseball, and after that the baseball attains the final velocity. Okay, so the initial velocity of the baseball, as you can see from this diagram, I'll draw the diagram here. This is U, which is equal to 30 meters per second, and it is at an angle of 15 degrees. After that striker, he strikes the ball. This is the final velocity, which is 30 degrees. Okay, this is the velocity that we need to find. This is the velocity that we are interested into. Determine the magnitude of the average impulsive force imparted to the ball if it is in contact with the bat for 0.75 milliseconds. The time is also given in milliseconds. Okay, 1 second is 1000 milliseconds. So this will be 0.75 into 10 raised to minus 3 seconds, or rather we can say 7.5 into 10 raised to minus 4 seconds. The other things that are given in this question are actually to find this velocity which is after the impact, right? So it is really important to understand what is happening here. This U is the velocity when the by which the baseball is coming towards the striker. Okay, and that is why the direction is this way, like this. And this V is the velocity by after the striker has hit the ball. Okay, and now see, after the striker hits the ball traverses a parabolic trajectory, right? So by which velocity is it traversing this parabolic trajectory? It is going something like this, right? So the velocity by which it is traversing this parabolic trajectory is your V. Yes, and it is making an angle of 30 degrees this way. This distance is 100 meters, and from this point to this point the distance is 2.5 minus 0.75. See, this is 2.5 minus 0.75, which is equal to 1.75 meters. Okay, this is the horizontal component of velocity. We will say V cos 30, and the vertical component is V sin 30. Okay, the horizontal component of that of this velocity helps the ball traversing the horizontal distance. So what I can write is 100 is equal to v cos 30 into the time taken for this ball to reach from this point to this point. Let us say the time taken is t. Okay, so this is one equation that we can have. So I'll say t is equal to 100 upon v cos 30. Okay, another equation that we can have is this vertical distance that it is traversing is 1.75. So s is equal to ut plus half at square. What is your acceleration here? Acceleration is nothing but the acceleration due to gravity, which is always acting downwards. Therefore it is minus 9.81 meters per second square, and the initial velocity is v sin 30. So 1.75 is equal to v sin 30 into t. I'll write as 100 upon v cos 30, right? And plus half at square. So a we know is negative, so it will become minus half into 9.81 into 100 square upon v square cos square 30. If you solve this equation would be a quadratic equation, and when you solve this equation you will get v as equal to 34.1785 meters per second. So we have found the impact, after the impact, what was the velocity after the striker hit the ball. We found that velocity, right? Now we are in a position to apply the impulse momentum equations. So what I'll do is I'll apply impulse momentum equation first along the x direction, and then I'll apply it along the y direction. So impulse momentum equation along x direction, what are the forces here? So those forces actually we need to determine, right? Fx I'll write, Fx would be the force, since we need to determine the magnitude of the average impulsive force, right? So let's say Fx is that force which is acting in the x direction multiplied by what was the time of impact. The time of impact was 7.5 into 10 raised to minus 4 seconds. 7.5 into 10 raised to minus 4 seconds. This is your total impulse along the x direction, is equal to the mass of that ball is 0.15 kg. So 0.15 into Vx, the horizontal component of your velocity, which is v cos 30, I'll say. So it's v cos 30. Okay, and see, since the motion of that ball is along this direction, which we are saying is positive, therefore v cos 30 is positive, but u cos 15 would be negative. See, you can see here v cos 30 would be positive. Since the ball is traversing in this direction, we are considering that to be positive. So u cos 15 would be negative, minus u cos 15. We know v, we know u, everything we know. From this we can find Fx, and Fx comes out to be 11715.445 newtons. Similarly, if we apply impulse momentum equation along the y direction, we will get Fy into 7.5 into 10 raised to minus 4. Okay, this is the impulse, is equal to 0.15. And see here, do not consider the weight to be acting downwards, okay, because what is happening, what we are actually finding is the point where this person, the striker, hits with his bat, hits the ball, Okay, so let us say this is the ball like this. At this moment we are calculating everything. So let's say at this moment the Fx force is like this, Fx, and the Fy force is this way. Okay, so here that gravity won't come. So it is equal to mass into the velocity, final velocity Vy, which is upwards we are considering as positive. So V sine 30 minus this u will again have a downward component here, so that is again a negative thing, minus u sine 15. Okay, so V we know and u also we know. We can find Fy from here. Fy comes out to be 4970.7643 newtons. And now we can find the average force. Average force is nothing but F or the resultant force, Fx square plus Fy square under root of. So F comes out to be 12726.356 newton. So this is the force by which that striker strikes the ball, such that it attains a final velocity of 34.1785 meters per second. So that's it about the impulse momentum numericals. Till then, take care. Thank you.